Hello guys, I hope you are doing extremely great. Today we will be discussing lead code question number 3462, maximum sum with at most k elements. So in this question we have been given a matrix which has size n cross m and an integer array limits which has the length n. Also we have been given an integer k. So we have to find the maximum sum of at most k elements from the matrix grid such that the number of elements taken from each row does not exceed limits of I. For example, if the first elements of the vector limits is 3, so from the first row we can only take at most 3 elements from the first row of this matrix, right? Like let's say we have example 1. So the grid here is 1 2 1 comma 2 and then 3 comma 4, and the limits are 1 comma 2, which means that the first element is 1. So from the first row of this grid we can only take one element, and from the second row we can take both the elements 3 and 4, because the limits is 2, so we can take at most 2 elements. Okay, and the k is 2, so the output will be 7. Why? Because we choose to take the most number of, we have to get the maximum possible sum with at most 2 elements taken out of this grid, following this principle where the number of elements from each row must not exceed this value, right? So the value will be, of course, 3 plus 4 7. We can also choose 2 and then 4, but then the sum will be 6, which is not the maximum possible here. So this is how this question goes. Now let's try to discuss how we can solve it, right? So what I can do is I can just simply pick limits of I number of elements from each row. Like if we have this example 2 and the grid looks like 5 3 7 8 2 6, right, and the limits are 2 comma 2. So what I will be doing is I will pick the maximum 2 elements from both the rows, right? From here I will pick 5 and 7, and from the second row I will pick 8 and 6, and out of these 4 elements I will choose the biggest 3 elements and then get their sum. In this way I will get my answer, and I will also don't break any of the rules, because in my new set of these new values this condition of not exceeding limit will be followed, and also I will be taking the maximum. I will be picking at most k elements, and those elements will be the maximum one out of that set. So my answer will always be optimal. Also let's check the constants here. Also, as you can see, each and every element is bigger than 0, right? It is bigger than or equal to 0, right? So we are good here. Now if the elements were negative, what we could have done is we could have chosen all the positive elements, which should not, the count of whose should not exceed this limit, and they all should be non-zero, right? This would make it work. Now let's jump into the coding part. Okay, first let's declare the rows and columns. Right, n will be number of rows and m will be number of columns. Okay, great, nice. Now for each row we want limits of I number of elements which are maximum. So for that I'll iterate through all the rows and just sort those rows and pick the biggermost elements from there. Hmm. Let's sort it in reverse order. Also we have to declare another vector which is initially empty. Now from this sorted row we will pick the limits of I number of elements from the beginning. So minimum of m comma limits, right? I have done this minimum of m comma limits of I because what if this limits of I is bigger than m, right? To handle that edge case I have put this condition here. Now oh yeah, yep, right, we are done here. Our begin our end. Okay, okay, great. Now this vector elements we have to sort it also. So also let's sort it in reverse order again. Now out of these elements okay, right, so we are choosing the bigger most elements from this vector elements, right? So the sum plus equal to and then we'll in the end return this sum, right? Let's do some sanity check here. Okay. Great. Okay, let's run this code now. Oh, we have to typecast here. I almost forgot. Okay, it got accepted. Okay, this got accepted here, both the test cases. Now let's submit the code and see what happens. Yep, it got accepted. Okay, so now let's try to discuss the time complexity here. So the time complexity will be we are going through each row and then we are sorting each row. So the time complexity will be n. For this part the time complexity is gonna be n into m log m. Then we are sorting, so it will be again n into then it will be n into m log nm log nm. Okay, it will be at worst nm log nm. Then here also so the time complexity is of the order of n log n basically. Yeah, also we are taking the space, so the space will also be n into m in the worst case, right? So yeah, that was pretty much it, and I hope you liked my approach. Also please drop down any comments or any question slash feedback slash discussion you have in your mind, and I'm more than happy to discuss it with you. And then yeah, I hope you like the approach, and see you with the next one. Thank you, bye.